Okay, so in doing this problem here, we are told the velocity is t over e to the kt squared. So I'm going to rewrite this and go t e to the negative kt squared. I think it'll be easier to think about in this way. And I know at time 0, it is 1. So I know that s at 0 is equal to 1, which I think we'll need in b part. For a part, we want to find the maximum acceleration of the particle. Well, I know the acceleration is going to be the derivative of the velocity. I have to recognize that this is a product going on here, so I have to use the product rule. So it's going to be the derivative of the first, which is 1, times the second function, e to the minus kt squared, plus the first function times the derivative of the second. So the derivative of this one is just going to be e to the negative kt squared times, chain rule says derivative of that top, which is negative 2kt. Simplifying this bit, I'm going to pull out a factor of e to the negative kt squared, e to the negative kt squared, which leaves me with 1 here, 1 minus 2kt squared. Okay, so but if I want to find the maximum acceleration, I want the derivative of acceleration to equal 0. And that will give me a minimum or a maximum, then I have to check to see what's going on. So now I have to find the derivative of this. So again, if I'm going to do the derivative of the acceleration, I have to do the derivative of the first. So the derivative of the first, e is just e, times the chain rule of this says it's going to be negative 2k times t, times the second function, 1 minus 2kt squared, plus the first function times the derivative of the second. The derivative of this one, the 1 goes away, and I get negative 4kt. And so now I'm going to simplify this. I need to set it equal to 0. And the fact there's a k there means I can't just do it with my calculator. So if I consider what's going on here, I have to make sure that I pull out things that are common. Well, that's common in both, as is the negative 2kt, because there's a negative 2kt in there. So if I pull out negative kt times e to the negative kt squared, on this particular term, I'm left with 1 minus 2kt squared. And on this one, I'm left with a plus 2, because the k and the negative 2 and the t come out. And so I get negative kt e to the negative kt squared times 3 minus 2kt squared. And this is equal to 0. Well, if that is equal to 0, if I look carefully here, there's 3 factors here. Here's one factor, here's another factor, and here's a third factor. So negative 2kt could be 0, e to the minus kt squared could be 0, or 3 minus 2kt could also be 0. Well, if I solve for t here, I get 0. There's one possibility. This here, t e will never, a function, exponential function will never be 0, so that's impossible. And here I get t squared, oh, don't lose my squared. I get 2kt squared is equal to 3 if I bring that over. So t squared is equal to 3 over 2k. And I know that t then is equal to plus or minus the square root of 3 over 2k. And so now I have to check to see what's going on. So t equals 0 and t equals plus or minus root 3 over 2k. And I want to know when is it a maximum. Well, it's going to happen at one of those points. And I'm going to need to use my acceleration function, which is here's my acceleration function. If I put that down here, I'm going to have to plug 0 in and the other ones in to see what I get. And so if I plug in, let me switch to green. If t is equal to 0, well, then I get, so a at 0, e to the 0 is 1 times 1 minus t is 0, and this is also going to be 1, and so this is equal to 1. If I plug this t in, I get a at the plus or minus 3 over 2k, and I'm doing plus or minus because both terms are squared, so they'll end up being the same. So then it's e to the minus k times 3 over 2k, because the square root and the squares cancel, times 1 minus 2k times 3 over 2k. Which, if I think about this, the k's cancel, the 2k's cancel, and I'm left with here, I am left with e to the negative 3 times 1 minus 3, which is negative 2. So this is less than 0. It is negative. This is positive. So this one must be the maximum. And so the maximum occurs when t is 0 and a equals 1. So that is the term of the maximum acceleration of the particle. That's what this problem here is saying. So we've gotten that one. Let's try B part now. B part wants the set of values of k for which the particle will travel at least 5k. Well, if it's traveling, we are going to need the distance. And we know that the distance or displacement at 0 is 1. So in order to find the displacement function, I have to take the integral of the velocity function. And that is going to be, if I rewrite this as I did before, e to the negative k t squared dt. Well, I can see that the chain rule here, derivative is there. So I'm going to let u equal negative k t squared. So this is a u substitution. So du will be negative 2k t dt. Well, I have a t and a dt, so I'm going to move these over. So negative 1 over 2k du is equal to t dt. So if I do this substitution here, then this is a constant, so negative 1 over 2k, integrate e to the u du. If I take the actual integral, that ends up being times e to the u, and the u is negative k t squared plus some value c. But I know that when s is 0, I get 1. So 1 is equal to negative 1 over 2k times e to the 0 in here, which is 0, which is going to be 1 plus c. And so c is equal to 1 plus 1 over 2k. And so my s function is negative 1 over 2k e to the negative kt squared from here, plus the c value, plus 1 over 2k. Here is my distance function, displacement function. Now the question is asking for which values of k will the particle travel at least 5 meters. Well, I have to think about, as k changes, the function changes, I want the maximum to be at least 5. That's another way to think about this question. I want the maximum to be at least 5. If the maximum is 4.5, then we don't want that case. We want the maximum to be 5 or larger. The maximum of this function happens when when this value here gets really large. So as t goes off to infinity, then we hit our maximum. We want those values there because that will then eliminate this value because it's making it smaller and smaller. And so this makes this basically 0. And so I'm saying I want t to be 0, or sorry, infinity. And if t is infinity, I'm left with 1 plus 1 over 2k has to be bigger than 5. If I do some algebra on that, I subtract the 1 and it gives me 4. I'm going to multiply by the 2k, I get 8k. And I'm going to divide by 8. And so if I flip it around, k is less than or 1/8. So if k is less than 8, then I know that this function here will be 5 or more units away. It will travel at least 5 units away from the origin. So quite heavy in algebra, quite heavy interpretation, a lot of work to do on these.